An object which was initially at rest, it experienced a varying force, like in the graph you see this is the force varying, and it is applied on this box from 0 to 5 meter, then 25 to once again along 5 meter from 20 to 25 meter, and then once again from 35 to 40 meter it again applied for 5 meter. And during the distance when it was not exerted, this object was moving with constant velocity, and ultimately this object covered 50-meter total displacement. And don't forget that during this motion a constant frictional force 2 newton applied continuously on this object. So because the forward applied force is more than this frictional force, that's why this block will accelerate and it will gain the kinetic energy, and ultimately you have to find out the kinetic energy final at this much distance when it will cover 50th meter. Now because the force applied is not a constant force, it is the varying force, so only one way to find out the work done is by the finding the area under the graph. So you cannot apply fs cos theta because force is changing in the intervals. So this area will be equals to the work done by the applied force on this box, and that is equals to 1 over 2 into 5 meter into 80 meter newton. That is the area under the one triangle. So there are three triangles, so you either you can multiply it with 3. So it is 1200 divided by 2 joule, so it is 600 joule. This is the work done by the applied force. And don't forget the work done also by the frictional force should be negative because that's the constant force acting along the displacement 50 meter and cos 180, so that should be, so it is negative 100 joule. So what is the total work done as a result of these two forces acting on the box? That should be subtracted, so it is 500 joule. So this is the work done along this 50th meter. Now we will apply work energy principle to find out the final kinetic energy. So as you see it is moving on the horizontal surface, so there is a no change in gravitational potential energy, so work done should be equals to the change in kinetic energy only. The total work done we have found 500 joule is equals to, because the final kinetic energy minus initial kinetic energy, so you see that the initially the body was at rest, so that's why the final kinetic energy is equals to 500 joule. That is the answer. So B is the right answer.